Now we're going to look at graphing a piecewise function. So as we talked about in example one, you can have more than two pieces. In this case, there's three. Um, so again, there's three different functions. Over these domains are when these functions will appear on the graph. So we're going to look at the domain and the range for the entire thing, and then what intervals are increasing and decreasing. So that graph y equals 4x plus 11 is only for the x values between -10 and -2. So the orange graph starts at -10 and it goes all the way up to -2 for an x value. X squared minus 1 is for the values between -2 and 2. So you just have x, that parabola is only for between -2 and 2. And then x plus 1 goes from 2 out to 10. To determine the range, um, just looking, low to high. So for the first part, the low value is -29. The high part, well, the range of the entire function is 11. So the range is between -29 and 11. Um, yeah, and you can evaluate algebraically or just look at the graph for the 29 and the 11. Um, the domain of the function is for x, the lowest x is -10, the highest x is 10. So that's the domain given there in the range we just talked about. For where it's increasing, well, it's increasing over the orange part, right? So from -10 to -2, it's actually decreasing from -2 to 0, right? So for that first half of the blue part, it's a decreasing function. So it's decreasing from -2 to 0. And then from 0, so the second half of the blue part and all the green part, it's increasing. So from 0 to 10, it's considered increasing. All right, let's try a couple you try it's. Just scanning them both, honestly, I think the you try it number 3 is easier. So if you want to actually try that one first, be my guest. I'm just going to record it in the order that the slides come. But again, I think number 3 is easier than number 2. So let's do number 2. You can also choose, if you want to do number 2 together, meaning don't pause it and try it, just follow along with me first. That's an option as well. So if you want to pause it now, and then I'll explain number 2. Um, and then again, we'll do number 3 immediately after. All right, so you're just, again, graphing each of these 3 pieces over these 3 separate intervals. So I think the first thing I would do is I'm going to just figure out, well, what's 2x plus 5 is a line. So for 2x plus 5, we'll make an xy chart. I'm getting 2 ordered pairs. Since it's between -6 and -2, I'm just going to figure out what are the ordered pairs at those exact spots. Then I'm going to draw a line between them. So if I substitute -6, and again, this is an xy chart, for y equals 2x plus 5. If x is -6, -6 gets substituted in for x. 2 times -6 is -12, plus 5 is -7. All right, so the ordered pair -6, -7, it's like right here. Okay. And then if I substitute -2 in, -2 times x is -4, plus 5 is 1. So it's the ordered pair -2, 1. So if I go left 2 and up 1, it's like right here. All right. So then it's a straight line between that. I'm going to do my best to draw a straight line. Okay. And it is close points at both of those because it's less than or equal to for both those parts of the domain. Now let's do 2y equals 2x squared minus 7. I know that's a parabola. I know we haven't talked about parabolas yet, but you can really just get away with doing another xy chart for this. Here's what you know. The vertex of this is at 0. So I do want to know what's the x value at 0. And then I'll figure out what are the endpoints at -2 and then +1. So I'm going to figure out those 3 points. For 0, well, 0 squared is 0 times 2 is 0, so minus -7. So the ordered pair 0, -7 is down here. All right, -2. That -2 gets substituted in. -2 squared is 4. And then 2 times 4 is going to be 8. Which equals 1. So it's -2, 1. So interestingly, it is the exact same ordered pair that's here. So I'm just going to put an open circle around it, but it's noting the pink part is noting that it's still that function, but it has the same value. And when I substitute 1 in, 1 squared is 1 times 2 is 2. 2 minus 7 is -5. So it's 1, -5. And I'm making this an open circle. And the reason why, actually, it shouldn't go right there, right? Because we're scaling this by 2s. So it really should go in the middle here. So 1, -5. Again, the reason why it's an open circle is because of the less than or equal to's there, or not less, just less signs. And then it's a parabola, so it's just a curve. Okay. And then let's do the third part. So y is equal to negative. I'm going to write it as slope-intercept, so negative x minus 4. And I'm just going to do, since it's a line, I only just need to do the endpoints. So 1 and 3. I'm going to substitute 1 in for x. Be -1 minus 4, with -5. So it is the exact same ordered pair there. I'm just going to close the point there. And then for 3, it'd be -3 minus 4, which is -7. So at the ordered pair 3, it's going to go down to -7. So it'll look like that. Okay. If we want to talk about domain and range of that function, well, domain of that function is all right. So it's from -6 on the left to 3 on the right. So I'm just going to write it as a compound inequality. If you need an interval notation, it'd just be brackets around -6 and 3. For range, well, what's the highest point? Well, sorry, what's the lowest point? And that appears to be -7. And its highest point appears to be 1, just based on the calculations we already did. In terms of increasing and decreasing, it's increasing from -6 all the way up to -2. But it would be um, it would be from -6 up to -2. Notice how we're not including the or equal to part when we're talking about increasing or decreasing, because at the exact moment you get to the ordered pair at -2, an x value of -2, it stops increasing. It's not decreasing either yet. It's also increasing from 0 to 1. And then in terms of decreasing, it's decreasing from -2 to 0. And it's also decreasing from 1 to 3. Basically, any point is going down, right? Okay, so let's try the next you try question. So it's really the same thing. So again, I would pause it, try it, and then um, hit play when you want to check my solution. Um, okay, so again, three functions, the domains that, and broken up by those domains. So f of x equals y equals 3 is between -4 and -1. I don't really even need to do an xy chart um, because the y value is 3 for no matter what it is. So when x is -4, the y value is going to be 3. That's going to be an open circle because it says its x is greater than that -4, not greater than or equal to. So it's an open circle. And then over at -1, it's going to be a closed circle. It'll just be a horizontal line at 3 between them. Okay. Then for y equals -x, let's make an xy chart. I would do both sides, 0 and -2. 0 and +2, sorry. Um, well, opposite of 0 is, there is no opposite, so its y value would be 0 there, and then x would be negative. If x is 2, y is -2. So those are your two ordered pairs there. These are both closed circles because of the inequalities given in the domain. So it's the ordered pair 0, 0, and then 2, -2. So write 2 down 2. And it'll be the line in between that. And then three minus x. So I'm going to do 2 and 4. I'm picking 2 and 4 for my x values because those are the endpoints of the domain given. If I substitute 2 in for x, 3 minus 2 is 1. If I substitute 4 in for x, 3 minus 4 is negative. So those are my ordered pairs. These will both be open circles given the inequalities given in the domain. So 2, 1, right 2 up 1, open circle there. 4, -1 will be right 4 down 1. So here, then I connect them. All right, so that's what your graph looks like. The domain of the entire function. So like what does the function cover? Well, for domain, the x values that it covers are from -4 to -1. And again, it's less than because that was given, greater than, less than or equal to the -1 is there. I have to stop there because, well, I have to stop there and have a second part to this because Notice how there's nothing that's covering between -1 and 0. We don't have anything. So then it's going to go from 0 less than or equal to x out to 4. And that's just less than, because that's an open circle there. The open circle here in between is fine because it's closed down at 2 there, open there. You can't be closed at both places. So, but it counts as continuously going through. For range, you kind of have a similar issue where um, it's not continuous all the way through. So the first part I can say is the lowest part is at -2. And it's less than or equal to because it's a closed circle down there. It is covered by the red and the light blue all the way up until 1, which is just less than. And then we also have a range up here, just one spot at 3. Okay. And then if we're talking about increasing and decreasing, um, at no point is the function increasing. It's either constant, decreasing, or decreasing. Okay. So increasing is never. And then decreasing, it's decreasing starting up here and then until you get down to here. So um, it's decreasing the entire from 0 out to 4. Although technically, I suppose it's not decreasing at 2. So you actually need to break that up. So I apologize. So we're going to have to break that up and say it's decreasing from 0 to 2, and then it's decreasing from 2 to 4. Because technically at exactly 0.2, it's not decreasing for either the red or the blue. All right, let's try example 3.